Okay, so today, Algebra 2, we're working on quadratic functions still, but this time we're dealing with scale changes and reflections. This right here, I'm going to start by saying this is not the general form. This is the vertex form. So let's go ahead and correct that together. This right here is the vertex form. The general form is the one that looks like this. F of x equals ax squared plus bx plus c. That's the general form. The vertex form is the one where it has the vertex hidden inside. So, which is what we're using on. Today we're going to be talking about A and how A basically makes things either stretch, compress, or reflect, or whatever. So this is the quadratic parent function. We've already had these notes before, but I'm going to go ahead and fill this out so you can see these. This is for the base parent function. And the parent function, what that means is the simplest version of that particular equation. In this case, it's quadratics. The axis of symmetry, remember, is x equals h. Let's not forget that. And remember, it's that vertex thing right there. So axis of symmetry is x equals 0. The domain is always the same on these. It's always going to be infinity, all real numbers. The range, you're reading from top to bottom. So going at the very bottom, we're going to start going. We first see on this particular one values at 0. Remember, it's the y values. This is y values. Going from 0, and then you can see the arrows are going up forever into positive infinity. And that is squared because that vertex is on the line. So these are your basic notes right here beneath that shows everything you need to know. And I know a lot of y'all have a struggle reading this because it's just scary looking and it's math. But we've already done this before. The K, we already know the up and down. Vertical means up and down. So this is up and down. And then horizontal is left, right. So we already know that the H and K deals with that, essentially. And remember, when it's inside the parentheses, which it is for the left and right ones with the H, the X always lies. And the K always tells the truth over here. Now we're going to be dealing with reflections and vertical compression. So what I'm going to do now is I'm going to take you over to Desmos. So right here, we're going to talk about this for a second. I just wrote in a random equation. I just put a random equation in for those wondering. Right now, if there's no A in front, and A is where the 1 is, look what happens if I just have a 1 there. So when there's nothing there, it's technically a 1. Look what happens when I make a 2 there. Okay, I see what's happening. Look when I do 3, do 4, 5, 6. You see how when I put whole numbers in there, it starts putting it up like that? That is called, on these notes, right here, that is called a vertical stretch because it's like you're stretching it up for it. If you were to take like silly putty basically and stretch it between your fingers and pull one up and pull one down, that'd be the vertical stretch. A vertical compression is when it actually gets fatter. So when does it actually get fatter? Well, check it out. When it is a fraction. So there you go. See it getting fatter? Yeah, you can see it getting fatter when it's a fraction. So there's the 4, 5, 6, 7, 8, 9, 10, etc. So that's it. So the fraction ones, whenever you have the fractions, they're called, in this case, vertical compressions. And so it's kind of weird to think of it that way, but just remember, bigger than fractions is going to stretch it. Fraction is going to compress. So now we have to talk about, I'm going to move this back to 1. Now we have to talk about what happens when there's a negative in front. Boom, 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 boom. You see it? Negative, it flips out. That's that. That's what I wanted to show you on here, what those things do. So moving back to this thing, we're going to go ahead and move forward. And right here, function notation. I'm going to teach this a little differently than what we're doing in the other classes. I don't like this stuff introduced, like for instance in B right here. I don't like this right now. I don't want to do that. So my function notation is literally just replace the y with f of x. And I'll consider that good enough for now. I don't know if we ever have to revisit the function notation, and if we do, I'll teach it then. But for now, it's not going to show up on the final. The vertex in this, remember, our x's always lie, so this is a positive 1 here, and then our 3 is going to tell the truth, so we're good here. Our axis of symmetry is x equals 1, and I'm getting that from this right here, underneath here. We know right here, this is going to be a 2, so based on it being a big number, we know that's going to be a vertical stretch. So let's say vertical stretch, and you're going to say factor of 2 by factor of 2. I'm going to go on the next line, factor of 2. factor of 2. So like you just put the number there, meaning it stretches by a factor of 2 or it compresses by a factor of 1/2, etc. We know that it's going to move right 1. Remember, your x's always lie. It moves right 1, and we know it's going to move up 3. And there are no reflections. So there's basically 4 possible transformations you can have. You can have a left and right movement, you can have a stretch or compression, and then you can have a flip out where it flips over the x-axis, a reflection. So that's what we have. So let's go ahead and graph this. Let's see, we have vertex 1, 3, which is right here. And we know it's going to be going up because there's no negative in front of that 2 over here. And so what does this look like and how are we going to get there? Well, that's the fun part. So now that we know we're starting here, there's multiple ways you can solve for what you need to solve for next. You can look at the numbers here. You can technically look at this. You see this one here, a 0 and a 2, how they're next to each other. You can technically plug in a 0 and 2 into this equation and pop out what you need, which I'm going to show you now. So what does that look like? Y equals, because I know my vertex is right here. Actually, let me get rid of those blue dots right there. Because I know my vertex is right here. I know it's going up. I know that it's eventually going to cross around where the 4 is. It's going to cross somewhere around over here. So I know it'll cross at 0, where the x is. And then I know on my 2's it's going to cross over there. So I see these interests. So watch how I do this. Y equals 2. I'm going to plug in my 0 right here. Do you see the 0 on my x thing? Because I know it's going to cross over. I'm going to plug in this 0. So where my x equals 0, which is right here, and my x equals 2. Those are the things I'm interested in. So 0 minus 1 squared plus 3. And you can just evaluate that. Y equals, let's see, negative 1. Let's just write this out. Negative 1 squared plus 3. Do it again. Y equals, negative 1 squared is just 1. So 2 times 1 plus 3. And you have y equals 2 plus 3, which is 5. So we plugged in the point 0 right here. We ended up with 0, 5 for a point. So check it out. I can go up here, and I know it's going to cross right there. And then you really don't have to solve. If you know everything else going on, and you know it's going up, and you know it's going down, you can basically, using symmetry, see how far it is over there, and just go over and click it here. Why? Because I went 1 left where my x was, and I ended up intersecting here. And then I went 1 right, and I know from what I did I can intersect there. And then once you have those points, well, you don't want to draw it outside there. Well, that's a crappy drawing. Let's make that better. Once you have your points, you can essentially graph your parabola, your quadratic. And it looks a little bit like that. So that's it. That's one of the best ways going from scratch to just graph it. It's very simple. And again, you can technically do both points, but hopefully you can see the symmetry. And for those who can't see it, I'm going to go ahead and put this red right down the middle. That's my axis of symmetry, right? And so when I solved this point here, I was only 1 away from it. I was only 1 away from it right here. You see that? So all I have to do is go back and be like, oh, I can go right over and mirror it and put 1 more right over here. So that's kind of how that works. You'll need practice to get that down. It's pretty straightforward when you do it. So domain is always going to be the same, negative infinity to infinity. Range, we're reading our y values from bottom to top. So coming up, I don't see anything at negative 6, nothing at negative 2, nothing at 1. Suddenly we start at 3. We suddenly start at 3. So I'm starting at 3, and it's going to go up to positive infinity. And that's how we do that. So I'm going to go ahead and do one more problem real quick. Yeah, I don't want to repeat myself on this stuff because it's going to be the same thing over and over, essentially. But right here, I don't want to teach y'all this. I'm going to show this in class, but for those who are just getting this online, rewrite this like this. F of x equals 1/2 times x plus 4 squared minus 2. And then when it's asking for the vertex form, it's just like, what is it? And it's literally like this. So using the same technique that I used on the other, whatever it's called, the other problem number 1, I'm going to go ahead and quickly solve this for you. So checking this out, I know that I have a vertex at negative 4, comma negative 2. My axis of symmetry is x equals negative 4. Let's look at my transformations. Let's go look at our notes. What does it say over here? Our note says that when the a is between 0 and 1, a fraction, when it's a fraction, y'all, it's going to be a vertical compression. So let's go back to those notes. So this is going to be a vertical compression by a factor of 1/2. I'm going to say vertical compression by 1/2. Let's see, it goes to the left 4. It goes up. Oh no, it doesn't go up. It goes down 2. And then it's not negative, so it's just going to be like that. Okay, domain is always the same. Let's check out where this goes. So this is now at -4, -2. We're starting here. And now what I want to do is I'm going to plug in, let's see, I'm going to plug in -5 for my x value right here. So you see how I'm going to go. I know that I'm going to be going up. I know I'm going to be going this way, but what happens when I cross at -5, the x value? What's it going to do? So I'm going to go ahead and put that in, and I end up with 1/2 times -5 plus 4 squared minus 2. So I'm going to do that real quick. 1/2. -5 plus 4 is -1. -1 squared minus 2. So then 1/2 times 1 minus 2. And you get 1/2 minus 2, which is basically -1.5. And you can use calculators for that. I don't care how you get it. So it's about -1.5. So at -5 and about 1.5, right about here, is where I'm going to intersect. So I can use my axis of symmetry and just basically reflect over and do another one, and I essentially have my graph ready to go. That's supposed to be rounded, but I have a hard time drawing on this pad. So that's that for that problem. I'm going to go now to the next one. The last thing I'm going to show you, this one's going to, only difference on this one is a reflection that's going to have a negative. So write it like this: f of x equals -3, x plus 1 squared minus 1. So what's going to end up happening is your entire thing is going to go down. So you'll have a shape like this instead. So make sure you understand that. And then this one, I wanted to do a couple of these because I wanted to show you this. And I think I'm going to show you this in a different video, so y'all have this.